Tonight, we're diving into a cosmic disaster that would reshape everything about our world. Picture stepping outside tomorrow night and finding absolutely nothing where the moon should be. Not hiding behind clouds, not in a different phase, completely erased from existence. What seems like losing simple nighttime decoration would actually trigger Earth's most dramatic transformation in 4.6 billion years. We'll explore how this vanishing act would instantly destroy humanity's oldest timekeeping system. You'll see invisible forces that have been shaping our planet suddenly switch off, and we'll trace how Earth would wobble into a chaotic future where even the concept of stable seasons becomes meaningless. That silver companion hanging above us isn't just pretty scenery. It's been secretly running our planet's most fundamental operations since before life began. So settle in. Before we begin, leave a quick note in the comments, where you're listening from, or one thought you're carrying tonight. I read them, and they genuinely help shape future journeys. If you'd like more nights like this, subscribe, only if you enjoy these late-night journeys. Now let's begin. For over 50 centuries, human civilization has been dancing to the moon's rhythm. Every calendar we've ever created follows its beat. Every religious festival marks its phases. Every farmer's planting schedule obeys its cycle. This cosmic metronome has guided us with clockwork precision since before written language existed. The moment the moon vanishes, we'd lose the world's most successful timekeeping system. Chinese New Year becomes meaningless overnight. Islamic holidays lose their anchor to observable reality. Every lunar calendar that has guided human society for 5,000 years transforms into a historical artifact. We're talking about cultural devastation on a scale never seen in human history. Here's what makes this loss so devastating. Before humans learned to read words, they learned to read the moon. Ancient peoples across every continent independently discovered the same 29.5-day cycle. They used it to create the foundation for mathematics, astronomy, and agricultural planning. The moon taught our species how to think about time itself. Consider what disappears forever. These include Jewish holidays that have marked religious observance for over 3,000 years. They include Hindu festivals tied to lunar phases since ancient times. They include Native American traditions that have guided tribal life since before recorded history began. Even the English word month comes from moon. Without lunar phases, we'd need to reinvent one of our most basic time concepts. Perhaps most remarkably, humans would face living without the monthly rhythm that has shaped our species for 200,000 years. We'd become the first generation in human existence to organize time without watching the sky. The psychological disorientation alone would be staggering. Every second right now, an invisible giant pulls on our planet. The force measures about 2 times 10 to the 20 newtons of gravitational strength. That cosmic puppet master sits about 3.844 times 10 to the 5 kilometers away. It constantly tugs on Earth's oceans with precision that would make any engineer weep. Cut those invisible strings, and Earth becomes a marionette with no one controlling the dance. For 4.6 billion years, Earth and its lunar partner have been locked in an endless gravitational waltz. Both bodies constantly pull on each other as they orbit around their shared center of mass. That balance point lies buried 1,700 kilometers beneath our feet. Snap that connection instantly, and Earth lurches forward like a dancer whose partner just vanished mid-spin. Here's the mind-bending part. The effects wouldn't fade gradually over months or years. The instant the moon ceased to exist, Every single drop of ocean water would lose its lunar pull. That gravitational force has been lifting and lowering sea levels twice daily since Earth cooled. The system moving 1.3 billion cubic kilometers of seawater would simply switch off. It's like unplugging a machine that's been running since before complex life existed. The immediate transformation would be stunning in scope. Earth's rotation has been gradually slowing due to tidal friction. Our planet would suddenly lose its cosmic brake system. Earth's motion through space, shaped by the Earth-Moon gravitational relationship, would shift into a new configuration. We'd become something genuinely unprecedented in the solar system. Most remarkably, Earth would instantly join Venus and Mercury as major planets orbiting solo. Mars has 2 tiny captured rocks. Gas giants boast dozens of moons. Earth would become a cosmic loner. We'd lose the gravitational dance partner that helped stabilize planetary behavior since the solar system formed. Walk along any coastline today, and you're witnessing Earth's most reliable performance. Twice daily, billions of tons of seawater rise and fall in a choreographed dance. This ancient ocean ballet has repeated for over 4 billion years. Those rolling waves advancing and retreating across beaches represent the moon's gravitational signature written in moving water. Remove the lunar choreographer, and this performance transforms into something completely different. The moon currently generates about 68% of Earth's tidal force. Solar gravity provides the remaining 32%. Lose the lunar contribution, and our dramatic 6-meter tides shrink to gentle 2-meter oscillations. The sun's much weaker pull would power these modest ripples alone. Thunderous tidal bores that surge up rivers would become barely noticeable. Coastlines shaped by massive tidal ranges would face their first period of relative calm in geological history. But here's where the transformation becomes ecologically devastating. Intertidal zones would shrink dramatically. Those narrow strips of coastline get repeatedly flooded and exposed twice daily. Millions of species have evolved specifically to survive this transition between underwater and aerial environments. Barnacles, mussels, sea anemones, crabs, and countless marine organisms depend entirely on predictable tidal rhythms. They time feeding, reproduction, and survival around these cycles. The Bay of Fundy, famous for 16-meter tidal ranges, would become a quiet inlet. Water level changes would be barely noticeable. The Amazon River loses its massive twice-daily pulse. Tidal bores currently travel 800 kilometers upstream. That phenomenon would vanish. Coastal wetlands that filter pollution and protect against storms would drain back and shift dramatically. They'd transform into something unrecognizable. Perhaps most remarkably, ocean circulation patterns would weaken dramatically. Many depend on tidal mixing to maintain their strength. The Gulf Stream and other major currents partly rely on tidal energy. Weaker ocean circulation means less efficient heat distribution. Marine ecosystems have evolved around predictable tidal nutrients. They'd face unprecedented disruption. We'd witness the first major reorganization of coastal life in billions of years. Right now, Earth maintains a steady 23.5 degrees tilt. This gives us predictable seasons. Winter, spring, summer, fall arrive on schedule because our planetary axis stays locked in stable orientation. This cosmic reliability has persisted for hundreds of millions of years. Life has adapted to predictable climate patterns. But this stability isn't natural. It requires a cosmic anchor. Remove lunar gravitational influence, and Earth's rotational axis begins the most chaotic dance in planetary history. Computer models show our planet's tilt would start wandering. The range spans anywhere from 0 to 85 degrees over timescales of millions of years. Sometimes Earth would spin nearly upright. This creates permanent global summer with no seasonal variation. Other times it would tip so far that polar regions face the sun directly. Equatorial areas would experience months of darkness. Picture the climate chaos this unleashes. When Earth tilts beyond 45 degrees, polar ice caps melt completely during their direct sun periods. Sea levels rise by 60 meters. Then the same regions freeze solid during their dark phases. Massive amounts of water lock into ice. Sea levels drop dramatically. This isn't gradual climate change. It's geological scale climate seizures repeating every few million years. The agricultural implications would doom any complex civilization. Regions spent thousands of years developing climate-adapted farming. They'd face completely different conditions within a few generations. The Sahara Desert could become an ice-covered wasteland. Antarctica might develop tropical forests. Coastal cities would flood and drain repeatedly. Ice caps would grow and shrink with each axial shift. Mars offers a terrifying preview of our moonless future. The red planet lacks a large stabilizing moon. Its rotational axis has wandered wildly over geological time. Martian ice caps have migrated from pole to pole repeatedly. This created the chaotic climate history written in its geological record. Without the moon's steadying influence, Earth would begin this same unstable orbital dance. We'd become a planet where long-term climate prediction becomes impossible. What would happen the morning after the moon vanishes? Observatories around the world would face the most urgent scientific crisis in human history. Within hours, astronomers would confirm humanity's worst cosmic nightmare. Our companion, about 3.844 times 10 to the 5 kilometers away, had simply ceased to exist. No debris field, no gravitational signature, no explanation that fits any known physics. Just empty space where the moon should be. Emergency scientific committees would convene immediately. They'd need to assess the consequences. NASA's Jet Propulsion Laboratory would run computer simulations. These would show Earth's future orbital behavior. The European Space Agency would calculate new tidal predictions for coastal planning. Climate scientists would model the atmospheric effects of reduced tidal mixing. Marine biologists would prepare for the largest ecological disruption in 65 million years. Here's what makes this scientific challenge unprecedented. Every climate model has been designed around Earth's current lunar influence behavior. Every agricultural prediction assumes current conditions. Every coastal engineering project depends on existing tidal patterns. Weather patterns depend partially on tidal mixing in the oceans. Coastal ecosystems evolved around specific tidal ranges. Even GPS satellites would need recalibration as Earth's gravitational field subtly shifts. The most troubling realization would emerge from long-term projections. Astronomers would calculate that Earth's rotational axis will begin wobbling chaotically. This would happen within a few million years. Climate scientists would predict periods of extreme glaciation. These would alternate with complete ice cap melting. Geologists would forecast massive sea level changes. These would reshape continental coastlines repeatedly. Perhaps most remarkably, scientists would face explaining a harsh reality to humanity. Our planet's 4.6 billion period of relative stability was ending forever. The moon hadn't just been providing pretty nighttime illumination. It had been acting as Earth's cosmic gyroscope. It kept our world steady enough for complex life to flourish. Without that stabilizing influence, Earth would join Mars as a planet with chaotic climate swings. These make long-term biological evolution extremely difficult. The scientific community would essentially be announcing that Earth's golden age of stability was over. Earth's coastlines have hosted the most reliable drama on the planet for billions of years. Twice daily, massive walls of water charge up beaches like aquatic cavalry. Then they retreat in thunderous defeat. The Bay of Fundy's 60-meter tides could swallow a 4-story building. California's Morro Bay sees 2-meter swells that reshape entire beaches. This oceanic theater has been running the same show since before complex life existed, until the moon vanishes and the curtain falls forever. The morning after our lunar companion disappears, coastal residents worldwide would wake to an eerie sight. Those dramatic 6-meter tides that have been pummeling shorelines since Earth cooled. They'd shrink to modest 2-meter ripples. The sun's much weaker gravitational influence would power these gentle oscillations alone. It's like replacing a powerful orchestra conductor with someone gently tapping a dinner fork against a wine glass. Here's where the physics gets genuinely weird. Tidal force follows an inverse cube law. This means the moon's gravitational influence drops off incredibly rapidly with distance. Our sun weighs 27 million times more than the moon, but it sits 400 times farther away. That distance penalty is so severe that lunar gravity generates 2.2 times stronger tides despite the massive weight difference. Remove the moon, and we lose about 68% of Earth's tidal power instantly. The transformation would be immediate and global. Maine's famous rocky coastlines have been carved by millennia of massive tidal ranges. They would face their first period of relative calm in geological history. The Amazon River sees tidal bores surge 800 kilometers upstream twice daily. It would become a peaceful waterway with barely noticeable water level changes. Coastal communities have scheduled fishing, shipping, and daily life around predictable tidal cycles for thousands of years. They would suddenly inhabit a much quieter aquatic world. Perhaps most remarkably, humans would witness something unprecedented in Earth's history. Oceans that behave politely. No more surprise high tides flooding coastal parking lots. No more dramatic low tides stranding boats in harbors. The restless seas that have shaped coastlines and civilizations would suddenly develop impeccable manners, and lose most of their geological personality in the process. Imagine the sun as Earth's backup tidal manager, suddenly promoted to head of operations. Our star has been quietly contributing about 1/3 of Earth's tidal energy. The moon handled the heavy lifting. Now the sun faces the impossible task of single-handedly orchestrating oceanic movements across an entire planet. The results would be like watching an understudy attempt to perform a complex symphony with half the instruments missing. Solar tides follow a completely different rhythm than lunar ones. Instead of the familiar 12.5-hour cycle between high tides, we'd shift to a 12-hour solar pattern. High tide would occur precisely at noon and midnight every day. Low tides would arrive at 6 a.m. and 6 p.m. This mechanical precision might sound appealing until you realize something important. It eliminates the complex tidal variations that have driven coastal ecosystems for eons. The sun's tidal influence peaks during new and full moon phases. These are times when lunar and solar gravity normally combine forces. Without the moon's contribution, these spring tide periods would become barely noticeable events. Meanwhile, the moderate neap tides occur when lunar and solar forces partially cancel each other. They would simply disappear from coastal vocabulary. We'd trade Earth's rich tidal complexity for monotonous solar regularity. Here's where the inadequacy becomes obvious. Solar gravity creates tides about 46% as strong as lunar tides. Combine that with losing 68% of total tidal force. Coastal areas would experience something like watching a whispered conversation after years of listening to rock concerts. The Mediterranean Sea currently experiences minimal tides due to its enclosed nature. It would become the model for how all Earth's coastlines behave. Most remarkably, the Sun's solo performance would reveal something profound. It would show just how perfectly the Earth-Moon system has been choreographed. Lunar tides arrive at different times each day. This creates the complex patterns that mix ocean waters and drive coastal currents. Solar tides, locked to our 24-hour day cycle, would produce far less mixing and circulation. Earth's oceans would essentially downgrade from dynamic, ever-changing systems to relatively static bodies of water. The cosmic conductor would be replaced by a metronome. Every day at 3:47 p.m. something remarkable happens. The barnacles on Pier 39 in San Francisco prepare for their favorite meal. As the tide rises, these seemingly motionless creatures transform into feeding machines. They extend feathery arms to capture plankton from the rushing water. 6 hours later, they'll hunker down for the low tide period. They conserve moisture until the next feeding opportunity arrives. This twice-daily rhythm has guided coastal life for hundreds of millions of years, and it's about to be catastrophically disrupted. Intertidal zones represent some of Earth's most productive ecosystems precisely because they're regularly stressed. Twice daily, these narrow coastal strips transform from underwater habitats to aerial environments. Only the toughest, most adaptable species survive this constant transition. Mussels clamp shut to retain moisture. Sea anemones retract into protective shells. Crabs scuttle between tide pools. This harsh environment has forged incredibly resilient life forms, but resilience has limits. Reduce tidal ranges by 2/3, and the intertidal zone essentially vanishes. Those dramatic rocky coastlines tell a story. Waves crash against barnacle-covered rocks during high tide. They reveal complex tide pool communities during low tide. These areas would become permanently submerged or permanently exposed zones. No transition area would remain. Millions of species evolved specifically to exploit this twice-daily environmental shift. They would face immediate extinction pressure. The ecological cascade would be devastating. Shorebirds time their feeding to low-tide exposures. They would lose access to crucial food sources. Sea otters hunt for shellfish in intertidal areas. They would find their prey either permanently underwater or permanently out of reach. Coastal plants adapted to salt spray from dramatic tides would face drought conditions. Wave action would diminish significantly. Perhaps most tragically, tide pool ecosystems would largely cease to exist. Those miniature aquatic worlds fascinate children and marine biologists alike. These complex communities depend on the twice-daily cycle of submersion and exposure. This maintains their delicate balance of predators, filter feeders, and algae. Without dramatic tidal ranges creating these temporary habitats, Earth would lose something precious. Some of its most accessible and beautiful examples of marine biodiversity would disappear. The coastlines that have served as natural classrooms for understanding ocean life would become monotonous, static environments. Earth's oceans operate like a massive transportation network. Currents serve as highways that move heat, nutrients, and marine life around the planet. The Gulf Stream carries tropical warmth from the Caribbean to northern Europe. The California Current brings cool water southward along the Pacific coast. These oceanic highways have been running on schedule for millions of years. Wind powers part of their operation. The constant stirring action of tidal forces provides additional energy. Remove the moon, and this global circulation system faces its first major breakdown in geological history. Tidal mixing provides about 30% of the energy that drives deep ocean circulation. Twice daily, tidal forces push surface water down and pull deep water up. This creates vertical mixing that prevents oceans from separating into stagnant layers. This constant stirring distributes oxygen to deep waters where marine life depends on it for survival. It also brings nutrient-rich deep water to the surface. This feeds the microscopic plankton that form the base of ocean food chains. Weaken tidal mixing by 2/3, and the consequences ripple through every marine ecosystem. The thermohaline circulation would slow significantly. This is the global conveyor belt of ocean currents driven by temperature and salinity differences. Warm surface water would stay warm. Cold deep water would stay cold. The efficient heat distribution that moderates Earth's climate would become far less effective. Regional effects would be dramatic and immediate. The North Atlantic currently receives heat from the Gulf Stream. This delivery equals the energy of 1 million nuclear power plants. The region would begin cooling as this thermal highway weakens. The Mediterranean Sea already shows signs of stagnation due to its enclosed nature. It would develop even more pronounced dead zones. Oxygen levels would drop too low to support marine life. Coastal upwelling zones bring nutrients to the surface and support some of the world's most productive fisheries. They would become far less active. Perhaps most concerning, the Arctic Ocean would lose much of its tidal mixing. This currently prevents it from becoming completely stratified. Arctic waters already show signs of increasing stratification due to climate change. Reduced tidal forces would accelerate this process. This could potentially create a polar ocean with a warm surface layer. It would sit on top of cold, stagnant deep water. This would fundamentally alter Arctic marine ecosystems. It would affect global climate patterns in ways scientists are only beginning to understand. Every major port on Earth operates under one fundamental assumption. Tides will continue behaving exactly as they have for recorded history. Harbor engineers calculate dock heights based on centuries of tidal data. Shipping schedules coordinate with predictable high and low tide timing. Marina designers build boat slips to accommodate specific tidal ranges. The morning after the moon vanishes, this massive infrastructure investment becomes spectacularly obsolete. Consider Portsmouth Harbor in New Hampshire. Engineers designed it for 3 mid-tidal ranges. Ships currently time their arrivals for high tide to clear the harbor's shallow entrance. Reduce that range to 1 meter, and larger vessels would face a dilemma. They'd be permanently trapped or permanently excluded. The harbor would need complete redesign or face economic irrelevance. Multiply this problem across thousands of ports worldwide. You're looking at the most expensive infrastructure crisis in human history. The timing disruption alone would create chaos in maritime commerce. Liverpool's docks have operated on a 12.5-hour tidal cycle for over 300 years. Suddenly switching to precise 12-hour solar tides would require massive coordination. Every shipping schedule on Earth would need recalculation. Tidal power plants in France, South Korea, and Canada would become expensive monuments to obsolete technology. Coastal cities depend on tidal flushing to clear harbors of sediment and pollution. They would face permanent water quality problems. But here's where the crisis becomes truly expensive. Most of the world's major ports occupy locations specifically chosen for their tidal advantages. San Francisco Bay's Golden Gate allows massive tidal flows. These keep the harbor naturally dredged. The Thames estuary's tidal bore helps ships navigate upstream to London. Rotterdam's complex tidal patterns have shaped centuries of Dutch maritime engineering. These locations would retain their geographic advantages for wind protection and deep water access, but they'd lose the tidal dynamics that made them optimal harbor sites. Perhaps most remarkably, humanity would face rebuilding maritime infrastructure. This system has been optimized for lunar-influenced tides since ancient Phoenician traders first mapped coastal harbors. Every lighthouse timing system assumes current conditions. Every harbor depth chart relies on existing patterns. Every coastal navigation aid expects Earth's current tidal behavior. The accumulated knowledge of generations of sailors, harbor pilots, and marine engineers would become historical curiosity overnight. Coastal communities worldwide would essentially need to relearn how to live and work with their newly calmed seas. Earth spins at a reassuring 23.5 degrees of tilt right now. This delivers predictable seasons with Swiss clockwork precision. Summer arrives when your hemisphere leans toward the sun. Winter comes when it tilts away. This cosmic reliability has persisted for hundreds of millions of years. Life evolved around dependable climate patterns. But this stability isn't natural. It requires a massive celestial anchor sitting about 384,000 kilometers away, plus another 400. The moon constantly tugs our planet back into proper alignment. Remove that lunar anchor, and Earth's rotational axis transforms from a stable spinning top into a cosmic pinball. Computer models reveal our planet's tilt would begin wandering chaotically. The range spans anywhere from perfectly upright at 0 degrees to nearly sideways at 85 degrees. This would happen over timescales of millions of years. This isn't gradual drift. It's chaotic lurching that would make Earth's climate utterly unpredictable across geological time. The physics behind this instability reads like a textbook on cosmic chaos theory. Earth's equatorial bulge creates what physicists call gravitational torque. That slight fattening around our planet's middle comes from rotation. When other celestial bodies pull on it, problems develop. Currently, the moon's steady gravitational influence keeps this torque from building up into dangerous wobbling. Without lunar stabilization, gravitational influences from Jupiter, the Sun, and even Venus would gradually accumulate. They'd create massive axial shifts. Mars offers a terrifying preview of our moonless future. The red planet lacks a substantial moon. It has experienced wild axial variations throughout its history. Martian ice caps have migrated from pole to pole repeatedly. The planet's tilt wandered between 15 and 60 degrees. The geological evidence shows periods when Mars tilted so far that its polar regions received more direct sunlight than its equator. This created climate chaos that contributed to the planet's transformation into a frozen desert. Perhaps most unnerving, Earth's axial stability has been the invisible foundation for complex life. Reliable seasons enabled plants to develop predictable growth cycles. Stable climate zones allowed species to adapt to specific environmental niches. Remove the moon, and we'd essentially start a cosmic game of climate roulette. Long-term biological planning would become impossible. Earth would become a world where permanent is no longer part of the climate vocabulary. Try explaining seasons to someone after Earth's axis starts its chaotic dance. Sometimes your local Arctic would spend 6 months basking in direct tropical sunlight. The equator would experience prolonged darkness during the same period. Other times, Earth would spin nearly upright. This would eliminate seasonal variation entirely and create permanent global summer. This isn't science fiction. It's the inevitable result of losing our lunar stabilizer. When Earth's tilt exceeds 45 degrees, something extraordinary happens. Polar regions begin receiving more direct solar energy than equatorial areas during their summer periods. The North Pole would transform into a blazing solar furnace. Tropical regions would experience their longest nights. These aren't gentle seasonal transitions. They're geological scale climate seizures that would completely reshape Earth's temperature distribution. The most extreme scenarios occur when Earth tips beyond 60 degrees. At maximum tilt angles approaching 85 degrees, polar summers would become furnace-like. The same regions would freeze solid during 6-month polar nights. The seasonal temperature swings would be dramatic beyond imagination. The Arctic could experience both tropical heat waves and deadly deep freezes within the same year. No ecosystem on Earth has evolved to handle such extreme variations. Current polar regions house some of our planet's most specialized cold-adapted species. Polar bears, Arctic foxes, and countless marine organisms depend on consistently frigid conditions. Subject these creatures to equatorial heat levels during polar summer, and they'd face immediate extinction. Meanwhile, tropical species would need to survive months of near-Arctic conditions. This would happen when their regions tilt away from the sun. Perhaps most remarkably, the very concept of stable climate zones would become meaningless. Today's Arctic tundra could experience Caribbean-level heat during summer months. Then it would return to deadly sub-zero conditions for extended winter periods. The Sahara Desert might spend half the year under conditions similar to northern Canada. Earth would essentially become a planet where adaptation means surviving the most extreme temperature ranges imaginable. Every region would need to prepare for both desert heat and polar cold within the same calendar year. Antarctica contains enough ice to raise global sea levels by 60 meters if it melted completely. The Greenland ice sheet could contribute another 7 meters. For millions of years, these massive ice reservoirs have remained relatively stable. They grow and shrink gradually with long-term climate cycles. Lose the moon's stabilizing influence, and these continent-sized ice sheets become participants in history's most dramatic freeze-and-thaw cycle. During periods when Earth tilts beyond 50 degrees, polar regions would face something unprecedented. They'd experience their first direct tropical sunlight in geological history. The Antarctic ice sheet evolved over millions of years under consistently frigid conditions. It would begin melting at rates that make current climate change look glacial by comparison. Meanwhile, regions that tilt away from the sun would experience ice formation on unprecedented scales. These would exceed anything in Earth's recorded climate history. The sea level chaos would be staggering in scope. Polar ice caps would melt during their furnace periods. Coastal cities worldwide would disappear beneath 60 meters of sea level rise. Then Earth's wobbling axis would shift these same regions into prolonged darkness. Massive amounts of ocean water would freeze into new ice sheets. This would dramatically lower sea levels. Former coastal areas would be stranded dozens of meters above the new shoreline. This isn't the gradual ice age cycles that have shaped Earth's recent geological history. Those changes occurred over tens of thousands of years. Ecosystems had time to migrate and adapt. Earth's moonless ice dynamics would operate on timescales of millions of years. The timing would be chaotic and eliminate any possibility of biological preparation. Species would need to adapt to their habitats, transforming between underwater, tropical, and frozen conditions. No predictable pattern would exist. Perhaps most troubling, coastal infrastructure and human settlements would face impossible planning challenges. How do you build cities when you can't predict the future? Your location might be underwater, tropical, or ice-covered within a few million years. The entire concept of permanent coastal development would become obsolete. Earth's shorelines would become temporary features in constant flux. Long-term civilization would become extremely difficult to maintain. Agricultural planning currently depends on one fundamental assumption: climate zones stay put. The Great Plains remain temperate, grassland ideal for wheat farming. The Amazon basin stays humid and tropical. The Sahara Desert maintains its arid characteristics. These stable climate patterns allowed human civilization to develop specialized agricultural techniques. Each technique was optimized for specific environmental conditions. Remove lunar stabilization, and this entire system collapses into unpredictable chaos. Earth's axis would wobble between extreme angles. Climate zones would migrate across continents like restless nomads. The Sahara Desert is currently locked in its arid location by stable atmospheric circulation patterns. It could find itself receiving Arctic-level sunlight when Africa tilts away from the sun during extreme axial periods. Meanwhile, Canada's boreal forests might experience tropical conditions. This would happen when the northern hemisphere tips into direct solar exposure. The atmospheric circulation changes would be equally dramatic. Earth's current wind patterns depend entirely on temperature differences between equatorial and polar regions. The trade winds, westerlies, and polar easterlies follow predictable patterns. Scramble those temperature gradients by tilting polar regions into tropical positions, and global wind patterns would reorganize completely. The jet stream would wander aimlessly. Hurricane formation zones would shift unpredictably. Monsoon seasons would arrive in completely different regions. Regional examples illustrate the scope of this climate chaos. California's Mediterranean climate is perfect for wine grapes and citrus fruits. It might transform into conditions resembling northern Alaska when North America tilts away from the sun. The Amazon rainforest could experience months of near-polar temperatures. These would be followed by periods of extreme heat that kill tropical vegetation. European agricultural regions have been cultivating specific crops for thousands of years. They would face environmental conditions that have no modern equivalent. Perhaps most remarkably, the entire concept of climate adaptation would require complete redefinition. Instead of adapting to specific, stable environmental conditions, life would need different strategies. Survival would mean handling the most extreme climate variations possible. Every ecosystem would essentially need to prepare for desert conditions, tropical heat, and polar cold. This would all happen within the same geological period. This represents a fundamental shift from Earth's current climate stability to a world where environmental chaos becomes the only predictable feature. Human agriculture represents 10,000 years of careful optimization. Everything depends on predictable seasonal patterns. Farmers plant wheat knowing spring will arrive on schedule. Vineyards cultivate grapes adapted to specific temperature ranges and rainfall patterns. Rice paddies depend on reliable monsoon cycles. This entire agricultural foundation rests on climate stability. That stability would vanish forever the moment Earth's axis begins its chaotic wandering. Within a few million years of losing lunar stabilization, agricultural regions worldwide would face impossible conditions. They'd encounter environmental extremes completely outside their adapted ranges. Iowa's Corn Belt might experience either tropical heat waves or Arctic conditions. This would depend on Earth's current tilt angle. France's wine regions could find themselves dealing with polar temperatures that kill grapevines, or desert conditions that eliminate soil moisture entirely. No crop variety on Earth has been bred to handle such extreme variations. The timing unpredictability makes agricultural adaptation nearly impossible. Ice ages develop gradually over thousands of years. Axial wobbling creates climate shifts on million-year timescales with chaotic patterns. Farmers couldn't prepare for coming changes because the changes themselves would be unpredictable. Agricultural research couldn't develop climate-adapted crop varieties. Nobody could forecast what climate conditions to prepare for. Livestock agriculture would face equally impossible challenges. Cattle breeds adapted to temperate grasslands would need to survive both desert heat and polar cold. This would happen within the same general time period. Dairy cows require consistent temperatures for optimal milk production. They would face temperature swings from tropical to subarctic. Sheep bred for specific wool characteristics in stable climates would need survival strategies. They'd need to handle the most extreme temperature ranges imaginable. Perhaps most critically, the accumulated agricultural knowledge of human civilization would become obsolete. Traditional farming techniques passed down through generations assume climate consistency. Seed timing, irrigation methods, pest management strategies, and soil conservation practices all depend on predictable environmental patterns. Earth's moonless climate chaos would essentially reset agricultural development to zero. Humanity would be forced to develop completely new farming approaches. These would be designed for a world where environmental stability no longer exists. Complex civilization as we know it would become nearly impossible to maintain on a planet. Even basic food production would face constant, unpredictable climate disruption. Deep within every human cell lies a molecular timekeeper. This internal biological clock has been synchronized with the moon for millions of years. Scientists call it the circadian rhythm system. It doesn't just track daily sleep cycles. It also maintains longer monthly patterns tied to lunar phases. Most people never consciously notice these patterns. These 28-day biological rhythms influence everything from hormone production to immune system function. Remove the moon, and you've essentially unplugged the cosmic metronome. This device has been keeping life's timing systems synchronized since complex organisms first evolved. The immediate disruption would be subtle but widespread. Many mammals, including humans, show statistical correlations between lunar cycles and reproductive timing. Sleep quality also varies with lunar phases. Even emergency room visits show lunar patterns in some studies. Scientists debate the exact mechanisms behind these connections. The moon's disappearance would eliminate whatever biological cues these systems have been using for reference. It's like removing the conductor from an orchestra. The musicians can still play, but their coordination gradually deteriorates. Marine life would face far more dramatic biological disruptions. Countless species time their reproductive cycles precisely to lunar phases. They use moonlight intensity and tidal timing as breeding signals. Coral reefs coordinate mass spawning events with specific moon phases. They release billions of eggs and sperm simultaneously into the water. Grunion fish beach themselves during California's highest tides to lay eggs in sand. Sea turtles navigate using lunar-influenced magnetic fields. They time their nesting based on monthly light cycles. The reproductive chaos would extend throughout ocean ecosystems. Many shellfish, crabs, and marine worms have evolved spawning cycles locked to lunar months. These species have been following the same 29.5-day schedule for millions of years. Suddenly eliminate that timing reference and their reproductive coordination collapses. Mass spawning events depend on synchronized timing across entire species. They would become scattered, random occurrences with much lower fertilization success rates. Perhaps most remarkably, humans would become the first generation in our species' 200,000-year history. We'd live completely divorced from lunar biological influences. Whether those influences are strong or subtle, their elimination would represent an unprecedented biological experiment. We'd essentially be testing whether human biology can function normally without the monthly cosmic rhythm. This rhythm has been part of our evolutionary background since before our ancestors developed agriculture, written language, or complex civilization. Every January, roughly 1.4 billion people celebrate Chinese New Year. The celebration follows ancient lunar calculations that predate most written language. Islamic communities worldwide organize religious observances around a lunar calendar. This system has guided daily life for over 1,400 years. Jewish holidays follow lunar months that connect modern celebrations to traditions spanning 3,000 years. The morning after the moon vanishes, these intricate calendar systems would become historical artifacts. They'd have no connection to observable reality. The Chinese calendar represents arguably the world's most sophisticated traditional timekeeping system. It coordinates lunar months with solar years through complex intercalary adjustments. Scholars calculated these adjustments centuries in advance. This mathematical masterpiece has guided agricultural planning, religious festivals, and social organization across Asia for over 4,000 years. Without visible lunar phases to track, the entire system becomes pointless overnight. Farmers would lose planning schedules. Families would lose traditional celebration timing. An entire civilization's approach to organizing time would simply evaporate. Islamic communities face equally profound disruption. The Hijri calendar depends entirely on lunar observations to determine month beginnings. This makes it impossible to predict exact dates far in advance. This uncertainty is considered spiritually significant. It requires community observation and verification of new moon sightings. Remove the moon entirely, and Islamic timekeeping loses not just its practical foundation but its theological meaning. Ramadan timing, Hajj scheduling, and daily prayer coordination would require complete reinvention. The ripple effects would extend far beyond religious communities. International business operates around these traditional calendar systems. Chinese New Year shuts down manufacturing across Asia for weeks. Islamic holidays affect oil markets, shipping schedules, and international trade. Academic institutions worldwide coordinate exchange programs and international conferences around traditional calendar systems. The global economy has adapted to accommodate humanity's ancient lunar timekeeping methods. Perhaps most poignantly, children born after the moon's disappearance would never experience humanity's oldest form of cosmic education. For thousands of years, parents have taught children to count by watching lunar phases. Traditional stories, agricultural wisdom, and cultural knowledge have been transmitted through lunar calendar frameworks. These moonless generations would grow up disconnected from the primary educational tool. This tool helped human civilization develop mathematical thinking, pattern recognition, and long-term planning skills. They'd be the first humans in history to learn about time without any reference to the cosmic cycles that shaped their ancestors' understanding of temporal patterns. Human reproduction operates on mysteriously precise timing that has puzzled scientists for decades. The average menstrual cycle spans 28 days. This is remarkably close to the moon's 29.5-day cycle around Earth. Modern research debates whether this represents evolutionary adaptation or cosmic coincidence. Women throughout history have tracked fertility using lunar phases with surprising accuracy. Traditional midwives across cultures have correlated birth rates with moon phases for millennia. Remove the lunar reference entirely, and we'd essentially be conducting an unprecedented experiment. This would test human reproductive biology in ways never seen before. Sleep patterns would face immediate disruption across numerous species. Many animals show increased activity during full moon periods. Scientists call this behavior pattern lunar phototaxis. Humans demonstrate measurable sleep changes during full moon nights. They fall asleep later, sleep less deeply, and wake more frequently. Artificial lighting has reduced these effects in modern urban environments. The complete elimination of lunar light cycles would affect sleep quality for millions of people. Many still respond to natural light variations. The disruption extends beyond humans to countless species whose internal biological clocks depend on lunar timing. Nocturnal hunters have evolved activity patterns synchronized with lunar brightness levels. Many predators increase hunting during dark new moon periods. Prey animals have less visibility during these times. Migratory species coordinate movement timing with lunar phases. These provide optimal navigation lighting. These finely tuned biological relationships have been developing for millions of years. They can't adapt quickly to sudden lunar disappearance. Hormonal production in many mammals shows monthly fluctuations that correlate with lunar cycles. The exact mechanisms remain scientifically mysterious. Melatonin levels, cortisol production, and other hormone cycles might be influenced by subtle gravitational changes. Electromagnetic variations associated with lunar phases could also play a role. These effects are often small, but their complete elimination could have cumulative health impacts. The consequences wouldn't become apparent for years or decades. Perhaps most intriguingly, humans would lose their connection to a biological rhythm. This rhythm may have helped shape our species' cognitive development. Some researchers theorize that lunar cycle awareness contributed to early human development. It may have enhanced pattern recognition, mathematical thinking, and long-term planning abilities. Whether this connection is real or imagined, moonless generations would grow up without something important. They'd miss the monthly cognitive exercise of tracking natural cycles. This could potentially affect how human consciousness relates to time, pattern recognition, and environmental awareness in ways we can't currently predict. Banking systems worldwide operate on a fundamental assumption. Months provide logical intervals for financial planning. Monthly salaries, mortgage payments, rent collections, and subscription services all depend on this concept. They treat a month as a meaningful unit of time. Here's the awkward reality. The word month literally derives from moon. Our current calendar months represent artificial divisions. They were created to approximate lunar cycles while staying synchronized with solar years. Remove the moon, and suddenly this entire financial framework loses its cosmic foundation. The immediate practical chaos would be staggering in scope. Payroll systems manage billions of monthly transactions. These are based on calendar months that originally tried to match lunar timing. Landlords collect rent on monthly cycles that made sense when months tracked observable moon phases. Credit card companies calculate interest on monthly billing cycles. These derive from lunar calendar traditions. Insurance companies assess premiums monthly. Government benefits disperse monthly. The entire consumer economy operates around time intervals originally designed to follow the moon's behavior. International commerce would face unprecedented coordination challenges. Different cultures currently use various calendar systems. These incorporate lunar calculations alongside solar timing. Chinese business operates around Lunar New Year's and traditional festivals. Islamic banking follows lunar month requirements for certain financial instruments. Jewish commercial law includes lunar-based timing for contracts and agreements. Remove the common lunar reference point, and these different timing systems would need complete reconstruction. They'd use artificial intervals with no natural foundation. Corporate planning cycles would require fundamental reorganization. Quarterly earnings reports divide solar years into 4 periods. Monthly progress tracking within quarters relies on calendar months with lunar heritage. Project management systems use monthly milestones. These derive from traditional lunar calendar thinking. Supply chain logistics coordinate monthly delivery schedules. These are based on calendar months designed to approximate natural lunar timing. Marketing campaigns launch around traditional monthly patterns. These originally followed observable cosmic cycles. Perhaps most remarkably, humanity would need to invent entirely new temporal organization systems. These would be for managing complex society. The monthly interval has proven optimal for human psychological planning. It's long enough for meaningful progress, short enough for manageable commitment periods. Without natural lunar cycles to provide this timing framework, societies would need different solutions. They'd need to develop artificial monthly equivalents based on arbitrary mathematical divisions. These wouldn't be based on observable cosmic patterns. We'd essentially be redesigning time itself to replace the natural rhythms. These rhythms have organized human civilization since the dawn of agriculture. Earth's rotation has been slowing down for billions of years. The moon deserves most of the credit for this cosmic braking system. Tidal friction created by lunar gravitational pull acts like a gentle but persistent brake pedal. It's applied to our planet's spin. Currently, Earth days lengthen by about 1.7 milliseconds per century. This change is so gradual that human civilization has never noticed it. Remove the moon's tidal braking, and this slowdown process would continue. But it would happen at a dramatically reduced rate. It would take millions of years to produce measurable effects. The physics behind this deceleration reads like a cosmic engineering manual. Every tide that rises and falls on Earth's surface creates friction. This happens between moving water and stationary land. This friction converts Earth's rotational energy into heat. It gradually slows our planet's spin while simultaneously causing the moon to spiral slowly outward. It's the most patient energy transfer in the solar system. This process has been operating for 4.6 billion years. It would continue for billions more if the moon remained in place. Without lunar tidal friction, Earth's rotation would still slow down, but the process would become almost negligibly gradual. Solar tides would continue providing weak braking force. They operated only about 32% of the moon's effectiveness. Atmospheric drag from solar heating would contribute minimal additional slowdown. Wind patterns would create tiny amounts of rotational friction. The combined effect would extend Earth days at a much slower rate. Changes that currently take centuries would require millennia to develop. The long-term implications stretch across geological timescales that dwarf human comprehension. In Earth's current configuration, tidal forces would eventually slow our planet's rotation significantly. One day would eventually equal 1 month. This would create a tidally locked Earth-Moon system. The same hemisphere would always face the Moon. This process would take about 50 billion years. That's far longer than the sun's remaining lifetime. Without the moon, Earth would continue rotating at nearly its current speed for hundreds of millions of years. It would maintain 24-hour days far into the cosmic future. Perhaps most ironically, losing the moon would essentially preserve current day length far longer than keeping it. The lunar tidal break has been gradually lengthening Earth days for eons. That break would disappear, leaving our planet spinning at nearly constant speed indefinitely. Future civilizations billions of years from now would inherit 24-hour days similar to ours. They wouldn't get the month-long days that current tidal evolution would eventually produce. In the strangest possible way, losing our timekeeper would actually preserve time itself. It would ensure that Earth's daily rhythm remains recognizably human-friendly for cosmic ages to come. Astronomy enthusiasts have been cursing the moon for centuries. Every month, that brilliant disk washes out faint stars for roughly 2 weeks. It turns spectacular dark sky views into mediocre stargazing sessions. Astrophotographers plan their shoots around new moon periods. They want to avoid lunar glare ruining delicate galaxy images. Deep sky observers travel to remote locations specifically to escape moonlight pollution. The irony is perfect. Losing our closest cosmic neighbor would instantly create the best stargazing conditions in human history. A full moon reflects enough sunlight to reduce visible star count by about 90%. Professional observatories shut down sensitive instruments during bright lunar periods. Moonlight contamination makes precise measurements impossible. Amateur astronomers consider bright moon nights essentially worthless for serious observation. Remove that celestial spotlight entirely, and the night sky transforms into something previous generations could never have imagined. The Milky Way would become genuinely spectacular every single night. Currently, our galaxy's central bulge appears as a faint smudge. It's only visible during darkest new moon conditions. Without any lunar interference, those billions of distant stars would blaze across the sky like cosmic fireworks. Dark nebulae would stand out as dramatic silhouettes. Those mysterious dust clouds block background starlight. Star clusters invisible to naked eye observers would become easily visible fuzzy patches. Southern Hemisphere residents would gain the most dramatic improvement. The large and small Magellanic Clouds are companion galaxies to our own Milky Way. They currently require dark sky conditions to observe properly. In a moonless world, these cosmic neighbors would dominate the southern sky. They'd appear like permanent auroral displays. The Coal-Sack Nebula is that distinctive dark patch near the Southern Cross. It would appear as a striking black void silhouetted against the enhanced Milky Way backdrop. Perhaps most remarkably, urban stargazers would experience night skies that currently require wilderness expeditions to witness. Light pollution from cities would still exist, but eliminating the moon's brightness contribution would restore significant contrast to urban night skies. Millions of people living in metropolitan areas would suddenly gain access to celestial views. Previous generations could only experience these by traveling hundreds of miles from artificial lighting. The universe would literally become more visible to more humans than ever before in civilization's history. Nocturnal animals have been navigating by moonlight for millions of years. They developed sophisticated behaviors timed to lunar brightness cycles. A full moon provides about 0.25 lux of illumination. That's roughly equivalent to a candle flame at 10 meters distance. This seems dim to humans, but represents a crucial lighting difference. Creatures whose survival depends on precise night vision calculations rely on this illumination. Remove that light entirely, and you've essentially blindfolded millions of species. These animals have never experienced true darkness. Owls have a reputation for exceptional night vision. They actually hunt more successfully during moonlit periods when their prey becomes slightly more visible. These apex nocturnal predators would lose a significant hunting advantage in perpetually dark conditions. Barn owls, great horned owls, and countless other species have evolved hunting strategies. These depend on minimal lunar illumination to distinguish prey movement against darker backgrounds. The predator-prey balance would shift dramatically across every ecosystem on Earth. Small mammals currently avoid open areas during bright moon periods. They're more visible to aerial predators during these times. They would lose this protective timing cue entirely. Conversely, predators that rely on lunar illumination for successful hunting would face reduced prey capture rates. Millions of years of evolutionary night vision optimization would suddenly become mismatched to environmental conditions. Migratory species face the most severe navigation challenges. Many birds, sea turtles, and marine mammals use lunar position and brightness for navigation reference. This helps them during nighttime travel. Arctic terns migrate from Arctic to Antarctic. They'd lose a crucial navigation aid for their annual journey of 44,000 miles. Loggerhead turtles swim across entire ocean basins. They would need to rely entirely on magnetic field detection and stellar navigation. No lunar backup systems would remain. Perhaps most troubling, countless species have evolved activity patterns specifically synchronized to monthly lunar cycles. Some animals increase foraging during dark new moon periods. Predator visibility decreases during these times. Others time reproduction to full moon periods when increased visibility helps mate location. Eliminate lunar cycling entirely, and these behavioral patterns would become permanently misaligned with environmental conditions. Species would essentially need to redevelop millions of years of evolutionary timing optimization in real time. Many couldn't survive this adaptation challenge. Every summer night along Florida's Atlantic coast, something remarkable happens. Thousands of sea turtle hatchlings emerge from sand nests. They face the most critical navigation challenge of their lives. These quarter-sized babies must locate the ocean within minutes of hatching. Otherwise, they die from dehydration, predation, or exhaustion. For millions of years, they've solved this problem using a brilliantly simple strategy. They crawl toward the brightest part of the horizon. This has always been moonlight reflecting off ocean water. This ancient navigation system worked perfectly until humans invented artificial lighting. Coastal development now creates a deadly confusion called disorientation syndrome. Baby turtles crawl toward bright streetlights, hotel signs, and parking lot illumination instead of toward the ocean. Conservation groups spend millions annually on turtle-friendly lighting ordinances. Volunteer programs help redirect confused hatchlings seaward. Remove the moon entirely, and this problem becomes infinitely worse. Without moonlight providing natural ocean direction cues, baby turtles would lose their primary navigation system entirely. Ocean waves would still create subtle sound cues, but newborn turtles rely heavily on visual brightness gradients to determine seaward direction. In a completely dark environment, any artificial light source would become problematic. No matter how turtle-friendly its design, it would become the brightest available navigation beacon. Even minimal lighting from distant towns could misdirect entire generations of hatchlings. The navigation crisis extends far beyond sea turtles to countless marine species. Many use lunar positioning for oceanic travel. Many fish species migrate using moon position as a directional compass. Coral reef fish time spawning migrations to specific lunar phases. These provide optimal navigation conditions. Marine plankton perform vertical migrations timed to moonlight intensity. This affects entire ocean food chains. Remove the lunar navigation beacon, and millions of marine organisms lose their primary wayfinding system. Perhaps most tragically, conservation efforts designed to protect sea turtle reproduction would become largely meaningless. Current turtle protection focuses on preserving nesting beaches. It also works to reduce artificial lighting that confuses hatchlings. These efforts assume moonlight will continue providing natural seaward direction cues. Without the moon, even the most pristine nesting beaches couldn't help. Perfect lighting management wouldn't provide baby turtles with adequate navigation information. The species would need to evolve entirely new orientation systems. This process takes thousands of generations. It might not succeed before coastal turtle populations collapse entirely. Human civilization has been living with artificial lighting for over a century. We've gradually reduced our dependence on natural illumination cycles. Street lights, building lights, vehicle headlights, and digital displays have created perpetual twilight conditions. These exist in urban environments worldwide. Remove the moon's contribution to natural nighttime illumination, and this artificial lighting network would become humanity's sole source of after-dark visibility. The consequences would reshape energy consumption, urban planning, and social behavior. The immediate energy implications would be staggering in scope. Currently, outdoor lighting represents about 19% of global electricity consumption. Eliminate natural moonlight entirely, and this percentage would increase dramatically. Communities would struggle to maintain basic nighttime visibility for transportation, security, and commerce. Rural areas currently rely on minimal artificial lighting. They supplement this with periodic moonlight. They would need comprehensive illumination infrastructure for the first time in their history. Urban planning would require fundamental reconceptualization around permanent darkness. City designers currently assume some natural illumination exists during clear nights. This allows for moderate lighting levels that balance energy costs with visibility needs. Moonless cities would need dramatically increased lighting density. They'd need to maintain current safety and functionality levels. Sidewalks, parking areas, residential streets, and public spaces would all require enhanced illumination systems. Cultural and social patterns would shift toward complete dependence on artificial environments. Evening outdoor activities currently benefit from natural lunar illumination. Casual walks and sporting events get help from moonlight. This reduces artificial lighting requirements. Eliminate that contribution, and all nighttime human activity would need comprehensive artificial lighting support. Romantic evening beach walks would require flashlights. Outdoor concerts would need stadium-level illumination systems. Even simple activities like backyard barbecues would become dependent on artificial lighting infrastructure. Perhaps most remarkably, humanity would lose its last remaining connection to natural darkness cycles. These cycles shaped human evolution for millions of years. Our species developed in environments where monthly lunar cycles created natural variation. They alternated between bright and dark night conditions. Modern urban lighting has already eliminated this experience for most humans. Rural and wilderness areas still provide monthly darkness cycling. Without the moon, Earth would offer no natural reference for the darkness conditions that influenced human development. We'd become the first generation in human evolutionary history to experience permanent artificial lighting as our only nighttime illumination option. Constellation maps have guided human navigation and cultural storytelling for over 6,000 years. The Big Dipper helped Underground Railroad escapees find north during their journey to freedom. Polynesian navigators used star patterns to cross thousands of miles of open Pacific Ocean. Ancient Greeks created mythological stories around constellation shapes. These still influence literature today. Here's the remarkable opportunity. Losing the moon would create the darkest skies in human history. This would reveal stellar patterns and cosmic objects that no previous civilization has been able to observe with naked eyes. Professional astronomers would gain unprecedented access to faint astronomical objects. These have been previously hidden by lunar glare. The Andromeda galaxy currently appears only as a dim smudge during new moon periods. It would become a prominent, naked-eye feature spanning several degrees of sky. The Magellanic Clouds would blaze like permanent aurora displays in southern skies. Countless star clusters, nebula, and galaxies would emerge from invisibility. They'd become routine naked-eye objects for amateur observers worldwide. New constellation patterns would inevitably develop around these newly visible cosmic features. Instead of connecting bright stars into mythological figures, future astronomers might create different constellation maps. These would feature galaxy clusters, nebula complexes, and stellar associations. These are currently invisible to naked eye observation. The Coal-Sack Nebula might become as navigationally significant as the Southern Cross. The Pleiadian star cluster could serve as the centerpiece for entirely new stellar groupings. Cultural astronomy would experience revolutionary expansion. Indigenous communities, amateur astronomers, and educational institutions would gain access to cosmic phenomena. These previously required expensive telescopes to observe. Traditional star lore could incorporate cosmic objects that have never been part of human cultural awareness. Children would grow up with night sky experiences far richer than any previous generation. This could potentially inspire unprecedented interest in astronomical careers and space science education. Perhaps most remarkably, humanity would become the first intelligent species in cosmic history to experience something unique. We'd have optimal astronomical observing conditions simultaneously with advanced technological capability. Previous generations possessed either dark skies or sophisticated instruments, but not both. Our moonless civilization would inherit the darkest natural skies possible. These would combine with modern telescopic technology. This would create astronomical research opportunities that would revolutionize understanding of the universe. The loss of our cosmic companion would inadvertently provide the greatest astronomical gift in human history. We'd have perfect access to the cosmic neighborhood that the moon has been partially hiding for our entire existence as a technological species. Every November, the Great Barrier Reef hosts the planet's most spectacular underwater party. Millions of coral polyps release billions of eggs and sperm simultaneously into the water. Marine biologists call this the largest synchronized reproductive event on Earth. This oceanic explosion of life happens with Swiss watch precision during specific lunar phases. Tidal conditions optimize fertilization success during these times. The timing coordination spans thousands of square kilometers and involves hundreds of coral species. All follow the same celestial calendar they've used for millions of years. Remove the moon, and this reproductive masterpiece collapses into chaos. Coral spawning depends heavily on lunar cycle timing. Fertilization success rates plummet if different coral colonies release gametes even a few days apart. Ocean currents disperse reproductive material rapidly. Synchronized timing across vast reef systems requires a universal calendar. All coral species must be able to detect it simultaneously. For millions of years, that calendar has been lunar phases. These provide identical timing cues across entire ocean basins. The ecological consequences would cascade throughout marine ecosystems worldwide. Coral reproduction supports fish populations, sea turtle feeding cycles, and marine invertebrate communities. These depend on annual coral spawning events for nutrition. Many reef fish time their own reproductive cycles to coincide with coral spawning. They feed their larvae on the massive plankton blooms that follow successful coral fertilization events. Disrupt coral reproductive timing, and you've essentially pulled the foundation out from under entire marine food webs. Coral reefs represent just the beginning of oceanic reproductive chaos. Countless marine species coordinate spawning using identical lunar timing systems. Pacific Grunion fish beach themselves during California's highest spring tides. They deposit eggs in wet sand. Horseshoe crabs gather in massive mating aggregations during full moon periods. High tides provide optimal egg-laying conditions during these times. These species have been following lunar reproductive schedules for tens of millions of years. Few backup timing systems exist. Perhaps most remarkably, losing the moon would force rapid evolutionary changes. Marine reproductive strategies normally require millions of years to develop. Species would need to evolve new timing mechanisms based on temperature cycles, daylight variations, or chemical cues. These would replace lunar phases. Some populations might adapt successfully by developing alternative coordination systems. Others would face reproductive collapse and potential extinction. The world's oceans would essentially become a massive laboratory. This would test whether marine life can reinvent reproductive timing on evolutionary timescales measured in decades rather than millennia. Lions living in Tanzania's Serengeti follow the same dating calendar they've used for thousands of years. Female lionesses show increased mating behavior during full moon periods. Enhanced nighttime visibility improves hunting success during these times. It also reduces cub vulnerability to predators. Male lions respond to these lunar-influenced hormonal cycles. This creates population-wide reproductive timing that maximizes survival rates for the next generation. This precise coordination ensures cubs are born during optimal seasons. Pre-animals are abundant during these periods. Weather conditions support successful child rearing. Wolf packs across North America demonstrate even more dramatic lunar reproductive patterns. Alpha females typically give birth during spring months. This follows mating seasons timed to specific moon phases. Enhanced visibility during bright lunar periods allows pack hunting coordination. This provides pregnant females with adequate nutrition for successful pregnancy. Pack territory defense also benefits from moonlit conditions. These improve visual communication between pack members across large distances. The reproductive disruption would extend far beyond large predators. It would affect countless mammalian species worldwide. Many bats time mating seasons to lunar cycles. These optimize insect availability during pregnancy and nursing periods. Deer populations coordinate rutting behavior partly based on lunar timing. This affects hormone production and territorial behavior. Small mammals like mice and voles show statistical correlations between reproductive success and lunar phases. The exact mechanisms remain scientifically mysterious. Nocturnal species would face the most severe reproductive challenges. Their mating behaviors have evolved around monthly light variation cycles. Owls hunt more successfully during moonlit nights. They have developed reproductive timing that ensures adequate prey availability during chick rearing periods. Many nocturnal primates coordinate social behavior and mating calls around lunar brightness levels. These affect predator visibility and territorial communication effectiveness. Perhaps most troubling, these reproductive timing disruptions would occur simultaneously across all affected species. This would create ecosystem-wide population fluctuations that could destabilize predator-prey relationships. When multiple species lose reproductive coordination simultaneously, problems develop. The resulting population crashes and booms could trigger cascading effects throughout entire food webs. Ecosystems that have maintained stable predator-prey balances for millennia could face unprecedented fluctuations. Species would struggle to adapt their reproductive timing to a moonless world. The natural world would essentially need to reinvent population dynamics from scratch. Arctic terns perform the most extraordinary journey in the animal kingdom. They fly roughly 44,000 miles annually from Arctic breeding grounds to Antarctic feeding areas and back. These remarkable birds navigate across featureless oceans using sophisticated navigation systems. They combine magnetic field detection, star pattern recognition, and lunar positioning. This system has guided their species for millions of years. During nighttime portions of their marathon flights, lunar position provides crucial navigation backup. This helps when cloud cover obscures stellar references. It also helps when magnetic anomalies create compass confusion. Remove the moon, and you've essentially eliminated 1/3 of their navigation system. This affects the most challenging portions of their journey. Arctic terns aren't unique in their lunar dependence. Millions of migratory species use moon position as a navigational aid during long-distance travel. Many songbirds flying at night use lunar positioning to maintain proper heading. This helps when crossing large bodies of water where no visual landmarks exist. Seabirds traveling between distant islands coordinate their flights using lunar position. They combine this with wave pattern recognition. The navigation crisis would be most severe for species that migrate when other navigational cues become unreliable. Many birds crossing the Gulf of Mexico rely heavily on lunar positioning. The 600-mile overwater flight provides no visual landmarks. Magnetic anomalies in the region can disrupt compass navigation. Remove lunar reference points, and these flights would become significantly more dangerous. This could potentially lead to massive mortality events during peak migration seasons. Marine migrations would face equally devastating disruptions. Leatherback sea turtles navigate across entire Pacific Ocean basins. They use magnetic field detection combined with lunar positioning for course correction. Many whale species coordinate migration timing with lunar cycles. These affect ocean current patterns and prey distribution. Pacific salmon returning to natal streams use lunar-influenced magnetic field variations. This forms part of their remarkable homing system. Perhaps most tragically, these navigation failures would occur at the worst possible time for many species. This would happen during their most energy-intensive life stages when navigation errors prove fatal. Migrating animals operate on extremely tight energy budgets. They have no margin for error. Navigation mistakes that add even small distances to migration routes can exhaust energy reserves and cause death. Young birds making their first migrations would be particularly vulnerable. They lack the experience to compensate for missing lunar navigation cues using alternative methods. Entire generations of migratory species could face dramatically reduced survival rates. They would struggle to navigate a moonless world using incomplete navigation systems that have never operated without lunar backup. Modern sleep research has uncovered a puzzling phenomenon. It challenges our understanding of human biology. Despite living in artificially lit environments that should eliminate lunar influences, humans can still show measurable sleep pattern changes during full moon periods. Studies conducted in completely controlled laboratory environments reveal interesting patterns. These have no windows, clocks, or external light sources. People fall asleep an average of 5 minutes later and sleep 20 minutes less during full moon nights. These effects occur even when participants have no knowledge of current lunar phases. The mechanisms behind lunar sleep influences remain scientifically mysterious. The effects appear real and measurable across diverse populations worldwide. Some researchers theorize that subtle gravitational variations during different lunar phases might influence brain fluid circulation or hormone production. Others suggest that evolutionary programming from millions of years of lunar exposure has created biological timing systems. These respond to lunar cycles even in artificial environments. Remove the moon entirely, and humans would become unwilling participants. We'd join the largest sleep study in species history. We'd essentially be testing whether human circadian rhythms can function normally without monthly lunar variations. These have been part of our evolutionary background since before our ancestors developed agriculture. The results might not become apparent for years or decades. Sleep pattern changes often accumulate slowly over time. The disruption could extend beyond simple sleep timing. It might affect hormone production cycles that can show lunar correlations in some studies. Cortisol levels, melatonin production, and reproductive hormone fluctuations can show statistical relationships with lunar phases. These appear in certain research populations. These effects are often subtle and vary between individuals. Their complete elimination could have cumulative health impacts. These wouldn't manifest until moonless generations had lived their entire lives without lunar biological cues. Perhaps most intriguingly, humans would lose their last remaining connection to natural timing cycles. These influenced our species' development for millions of years. Our ancestors evolved in environments where lunar phases created monthly variations in nighttime light levels. They also affected predator activity and social behavior opportunities. Modern artificial lighting has already eliminated most of these experiences for urban populations. Complete lunar elimination would end this biological relationship for our entire species. We'd become the first humans in evolutionary history to live completely divorced from the cosmic cycles. These may have influenced the development of human consciousness, social behavior, and biological rhythms. The long-term psychological and physiological consequences of this disconnect remain completely unknown and scientifically unprecedented. When Earth first formed 4.6 billion years ago, our planet spun like a cosmic tornado. A single day lasted only 5 hours. Our newly formed world whirled through space at breakneck speed. Imagine trying to evolve complex life on a planet where sunrise and sunset occurred every 2.5 hours. This would create a strobe light environment that would make any ecosystem dizzy. This hyperactive spinning would have made Earth essentially uninhabitable. Only the simplest microorganisms could survive such conditions. The moon has been Earth's patient cosmic mechanic. It gradually applied the most gentle brake job in the solar system history. Tidal friction created by lunar gravity acts like a constant, invisible hand. It slowly reduces our planet's rotation. Every tide that rises and falls converts a tiny amount of Earth's rotational energy into heat. This steadily lengthens our days by about 1.7 milliseconds per century. It's the most persistent engineering project imaginable, A 4.6 billion year construction timeline would impress any project manager. This cosmic break job created the 24-hour day cycle that makes complex life possible. Plants need predictable light-dark cycles for photosynthesis optimization. Animals require consistent day-night patterns for circadian rhythm development. Weather systems depend on regular solar heating cycles for stable atmospheric circulation. Without lunar braking gradually slowing Earth's rotation, our planet would still be spinning at crazy speeds. These would prevent stable ecosystem development. The braking process continues today with mathematical precision. Earth's rotation slows by exactly 1.7 milliseconds per century. The Moon simultaneously drifts 3.8 centimeters farther away annually. This represents one of the universe's most elegant energy transfer systems. Earth's rotational energy converts to lunar orbital energy through gravitational interaction. It's cosmic engineering that operates so smoothly most people never realize it's happening. Perhaps most remarkably, this gradual day lengthening has provided billions of years of climate stability. This allowed life to evolve from single-celled organisms to complex civilizations. Early Earth's 5-hour days would have created extreme temperature variations, violent weather patterns, and atmospheric chaos. The Moon's patient braking system delivered the stable, predictable day-night cycles that enabled everything from tree rings to human sleep patterns. We're literally living inside the most successful cosmic renovation project in planetary history. Earth wobbles. Every planet wobbles as it spins through space. Gravitational tugs from other celestial bodies influence this motion. Internal mass redistribution from moving continents and ice sheets also contributes. But Earth's wobbling remains remarkably controlled compared to other planets. We have a massive stabilizing flywheel sitting about 384,000 kilometers away. It constantly corrects our planetary posture with gravitational precision. Without lunar stabilization, Earth's axial tilt would wander chaotically. The range would span between 0 and 85 degrees over millions of years. Mars demonstrates exactly what happens to planets without large stabilizing moons. Its axial tilt has varied between 15 and 60 degrees throughout geological history. This created wild climate swings that contributed to the red planet's transformation. It changed from a potentially habitable world into a frozen desert. Earth avoided this fate because the Moon acts like a cosmic gyroscope. It keeps our 23.5-degree tilt stable across geological timescales. This axial stability created the predictable ice age cycles that have shaped Earth's recent geological history. Regular variations in orbital geometry create the Milankovitch cycles. Those 100,000-year ice age patterns allowed life to adapt gradually to changing climate conditions. Without lunar stabilization, these predictable climate cycles would be replaced by chaotic axial wobbling. This would create random ice ages, unpredictable warm periods, and climate changes too rapid for biological adaptation. The stabilizing effect extends far beyond ice age cycles. It influences fundamental climate patterns that make complex life possible. Stable seasonal patterns allowed plants to develop predictable growth cycles. Regular temperature variations enabled animal migration patterns and breeding cycles. Consistent wind patterns created reliable ocean currents that distribute heat around the globe. The Moon essentially provided the climate stability that allowed Earth's biosphere to develop long-term evolutionary strategies. Perhaps most incredibly, this stabilization has been operating for billions of years with no maintenance required. The Moon formed through a giant impact event roughly 4.5 billion years ago. Since then, It has been faithfully maintaining Earth's axial stability while gradually moving farther away. This represents the most reliable climate control system imaginable. A natural gyroscope has prevented climate chaos across Earth's entire biological evolution. Every stable season, every predictable winter, and every reliable summer growing season exists because the Moon has been quietly maintaining Earth's cosmic balance. It's done this for longer than complex life has existed. Every 12 hours and 25 minutes, the Moon reaches up with invisible hands. It stirs Earth's oceans like a cosmic chef preparing the world's largest soup. This tidal mixing represents one of the most important yet underappreciated life support systems on our planet. Without this constant stirring action, Earth's oceans would stratify into stagnant layers, oxygen-poor dead zones would expand, and nutrient distribution would fail. This would create marine environments hostile to complex life. Tidal mixing provides roughly 30% of the energy that drives global ocean circulation. It constantly pulls nutrient-rich deep water to the surface. It pushes oxygen-rich surface water to the depths. This vertical mixing prevents oceans from developing the deadly stratification that kills marine ecosystems. The Bay of Fundy's 16-meter tides, the Mediterranean's gentle oscillations, and every coastal tide pool's twice daily refreshing represent something important. They show the Moon's ongoing efforts to keep Earth's water systems healthy and productive. The biological consequences of this mixing extend throughout marine food chains. Microscopic phytoplankton at the ocean's surface require nutrients brought up from deeper waters through tidal action. These tiny organisms produce over 50% of Earth's oxygen. They also form the foundation of marine food webs. Fish populations, well-feeding cycles, and coral reef productivity all depend on the nutrient distribution systems. Tidal mixing maintains these systems. Remove lunar tidal energy, and marine ecosystems would face oxygen depletion and nutrient starvation. The mixing benefits extend far beyond marine life to influence global climate regulation. Ocean circulation patterns, driven partly by tidal energy, help distribute heat from tropical to polar regions. This moderates Earth's temperature extremes. The Gulf Stream carries tropical warmth to northern Europe. It receives significant energy from tidal mixing. Deep ocean currents that transport heat and nutrients around the globe depend partly on the vertical mixing that lunar tides provide. Perhaps most remarkably, this oceanic mixing system has been operating continuously for over 4 billion years. It provided the marine environment stability that allowed life to evolve from simple ocean organisms to complex terrestrial creatures. Early life forms developed in oceans that were constantly mixed and refreshed by lunar tidal action. The oxygen levels that enabled complex cellular development were maintained by tide-driven circulation. The nutrient distributions that supported marine ecosystem development were established by billions of years of lunar mixing. The Moon has literally been feeding Earth's oceans since before life began. It created the aquatic conditions that enabled everything from algae to whales. Before humans invented fire, controlled lighting, or even basic tools, our ancestors faced a terrifying daily challenge. They needed to survive the night. Ancient Africa teemed with nocturnal predators. Lions, leopards, hyenas, and countless other creatures hunted when darkness provided them with overwhelming advantages over defenseless primates. Early humans possessed no night vision, no natural weapons, and no effective defense against predators. These creatures could see, hear, and smell far better in dark conditions. The Moon provided humanity's first security system. It offered natural illumination that enabled early humans to detect approaching predators. They could navigate safely between shelters and coordinate group defense strategies during dangerous nighttime hours. Full moon periods provided enough light for humans to spot the reflected eyes of approaching predators. They could recognize familiar landmarks and maintain visual contact with other group members. This lunar lighting advantage may have been crucial for human survival during our most vulnerable evolutionary period. Anthropological evidence suggests early human activity patterns correlated with lunar cycles. These patterns maximized survival advantages. Many primitive cultures developed traditions around full moon periods. Increased visibility enabled nighttime activities like travel, hunting coordination, and social gatherings. Cave paintings and archaeological sites show evidence of increased human activity during bright lunar periods. This suggests our ancestors learned to exploit moonlight for survival advantages. The psychological benefits of lunar illumination extended beyond simple predator detection. They influenced early human social development. Moonlit nights enabled extended social interaction periods. These may have contributed to language development, cultural transmission, and cooperative behavior evolution. The ability to remain active and social during some nighttime hours provided early humans with survival advantages. Purely diurnal species couldn't exploit these opportunities. Perhaps most intriguingly, the moon's protective illumination may have influenced fundamental aspects of human psychology and culture. These aspects persist today. Many humans still feel greater comfort and security during moonlit nights compared to completely dark conditions. Traditional cultures worldwide developed lunar-based festivals, ceremonies, and social traditions. These exploit natural nighttime illumination. The romantic and spiritual associations with moonlight that appear across human cultures might represent evolutionary programming. This comes from millions of years when lunar illumination literally meant the difference between life and death for our ancestors. The moon didn't just light our nights. It may have helped shape human consciousness itself. Long before humans developed written language, agriculture, or permanent settlements, our ancestors noticed something extraordinary. Something was happening in the night sky. That bright disk overhead appeared, grew larger, shrank, disappeared, and reappeared. It followed a perfectly predictable cycle that repeated every 29.5 days. This lunar rhythm became humanity's first lesson in mathematics, pattern recognition, and systematic thinking. These are cognitive tools that would eventually enable everything from calendar development to space exploration. The moon taught humans to count before they learned to write numbers. Early cultures worldwide developed counting systems based on lunar observations. They used fingers to track lunar phases and created the first mathematical concepts our species ever mastered. The word calculate derives from the Latin calculus, meaning small stone. Ancient peoples used pebbles to track lunar cycles. The moon essentially provided humanity's first calculator. It taught our ancestors that natural phenomena follow predictable mathematical patterns. Lunar cycle observation led directly to humanity's greatest intellectual breakthrough. This was the recognition that time itself operates according to discoverable patterns. This insight enabled agricultural planning, seasonal preparation, and long-term thinking. These abilities separated humans from other species. The ability to predict future events based on observed patterns became the foundation for scientific thinking, technological development, and complex social organization. The cultural impact of lunar timekeeping extends across every human civilization in recorded history. Chinese astronomers developed the world's most sophisticated calendar systems based on lunar observations. Islamic scholars used lunar calculations to develop advanced mathematics and astronomy. Mayan civilization created incredibly precise astronomical calendars centered on lunar cycle calculations. These intellectual achievements all trace back to early humans learning to recognize patterns in lunar behavior. Perhaps most remarkably, the moon provided the cognitive foundation that enabled humanity to develop abstract thinking, mathematical concepts, and scientific methodology. The recognition that celestial objects follow predictable patterns led to humanity's understanding of something profound. Natural phenomena operate according to discoverable laws. This insight enabled everything from architecture to engineering to space exploration. Every human intellectual achievement builds on the pattern recognition skills our ancestors first developed. They learned these skills while watching the moon cycle through its monthly phases. The moon didn't just teach humans about time. It taught us how to think systematically about the universe itself. Right now, as you read these words, the moon is quietly abandoning Earth. It moves away at the speed of growing fingernails. Every year, our lunar companion drifts 3.8 centimeters farther away. This change is so gradual that human civilization has never noticed it happening. This cosmic departure has been underway for 4.6 billion years. It represents the slowest breakup in solar system history. The same tidal forces that created our 24-hour days are simultaneously stealing our closest cosmic neighbor. The escape mechanism operates through the most patient energy transfer system imaginable. Every tide that rises and falls on Earth converts a tiny amount of our planet's rotational energy into lunar orbital energy. This happens through gravitational interaction. As Earth loses rotational energy, our days gradually lengthen. As the moon gains orbital energy, it spirals slowly outward. It moves like a ball on an invisible string that gets longer each year. This process has been operating with mathematical precision since the moon formed. Measuring this glacial departure requires the most sensitive instruments humans have ever built. Scientists bounce laser beams off reflective mirrors that Apollo astronauts placed on the lunar surface. They measure round-trip travel time to calculate exact Earth-Moon distances. These lunar laser-ranging experiments reveal the moon's recession rate with millimeter-level precision. They confirm that our cosmic companion has been steadily abandoning us throughout recorded history. The recession rate varies slightly depending on Earth's changing geography and ice distribution. It averages 3.8 centimeters annually across geological timescales. During Ice Age periods when massive ice sheets altered Earth's rotation, the recession rate fluctuated. As continents drift and ocean basins reshape over millions of years. Tidal friction patterns change subtly, but the overall trend remains constant. The moon has been moving away from Earth since it formed. It will continue this departure indefinitely. Perhaps most remarkably, this represents the most successful long-distance relationship in cosmic history. Despite gradually increasing separation for billions of years, Earth and Moon remain gravitationally bound. They will continue their cosmic dance until the Sun's evolution forces more dramatic changes. The Moon isn't abandoning Earth entirely. It's just slowly expanding the dancing floor while maintaining the same gravitational partnership. This partnership has shaped both worlds since the solar system's youth. This cosmic divorce is taking so long that it might never actually finalize. Every total solar eclipse represents a cosmic coincidence so precise it seems almost impossible. The moon appears exactly the same size as the sun in Earth's sky. The moon sits 400 times closer to Earth than the sun, but the sun measures 400 times larger than the moon. This perfect size matching creates total solar eclipses where the lunar disk precisely covers the solar disk. This reveals the sun's spectacular corona in a display of celestial theater. The phenomenon has inspired awe and terror throughout human history. This cosmic size matching is temporary and already changing. As the moon recedes 3.8 centimeters annually, it appears slightly smaller in Earth's sky each century. The angular size difference accumulates slowly. It's too gradual for humans to notice during lifetimes, but it inevitably approaches a threshold. Total solar eclipses will become impossible at that point. Astronomers calculate this eclipse extinction timeline with sobering precision. Total solar eclipses will end approximately 1 billion years from now. The transition from total to annular eclipses will happen gradually over millions of years. First, total eclipses will become shorter as the lunar disk barely covers the solar disk. Eclipse durations that currently last up to 7 minutes will shrink to seconds. Eclipse paths will become narrower as the moon's apparent size approaches the solar size limit. Eventually, even the longest total eclipses will last less than a minute. The moon's recession continues relentlessly. Future eclipse chasers, roughly 600 million years from now, will witness something poignant. They'll see the last long-duration total solar eclipses in Earth's history. These final magnificent total eclipses will be treasured events. Astronomical communities will recognize they're watching the end of a cosmic phenomenon. This phenomenon has inspired human civilization for millions of years. Eclipse tourism will reach unprecedented levels. People will travel worldwide to witness the final examples of totality. Perhaps most poignantly, the generation that witnesses Earth's final total solar eclipse will be saying goodbye to something irreplaceable. They'll lose a celestial spectacle that has inspired scientific discovery, religious experiences, and artistic achievement throughout human history. Ancient cultures built monuments to predict eclipse timing. Modern astronomy developed partly from eclipse observations. These revealed solar corona structure and confirmed Einstein's relativity theories. The cosmic coincidence that made total solar eclipses possible will expire naturally. Future civilizations will have only annular eclipses, where a ring of sunlight remains visible around the moon's silhouette. Earth's greatest astronomical show will close forever. Earth's dramatic tidal ranges represent a temporary geological phenomenon destined for gradual extinction. The same lunar recession that will eliminate total solar eclipses will also slowly drain the energy from our planet's tidal system. This will happen over billions of years. As the moon retreats to greater distances, its gravitational influence on Earth's oceans diminishes. This follows inverse square law physics. Tidal ranges that currently create 16 meters fluctuations in the Bay of Fundy will gradually shrink. They'll move toward the gentle oscillations powered solely by solar gravity. The mathematical relationship governing tidal decline follows predictable physics. Gravitational force decreases with the square of distance. This means the moon's tidal influence weakens rapidly as recession continues. When the moon reaches 60% greater distance from Earth, something significant happens. This will occur roughly 5 billion years from now. Lunar tidal forces will drop to about 40% of current strength. Combined with solar tides, Earth's total tidal energy will decline to roughly half of today's levels. This gradual tidal weakening will reshape Earth's coastal environments across geological timescales. These timescales dwarf human comprehension. Intertidal ecosystems currently depend on dramatic twice-daily water level changes. They will slowly transition toward permanently submerged or permanently exposed conditions. The tidal mixing that currently prevents ocean stratification and maintains marine productivity will gradually diminish. Ocean life will need to adapt to less dynamic aquatic conditions. Ocean circulation patterns driven partly by tidal energy will weaken as lunar influence fades. This will happen across billions of years. The Gulf Stream, thermohaline circulation, and other current systems depend partially on tidal mixing. They will need to operate with reduced energy input. Global climate patterns influenced by ocean heat distribution could shift. Tidal contributions to oceanic circulation will slowly disappear from Earth's climate equation. Perhaps most remarkably, this tidal decline represents a return toward Earth's original state. This existed before the Moon's formation 4.5 billion years ago. Early Earth experienced only weak solar tides before the giant impact event created our lunar companion. The dramatic tidal ranges that have shaped coastlines, mixed oceans, and influenced biological evolution throughout Earth's history represent something temporary. They show an enhancement to our planet's natural tidal state. As the Moon gradually returns toward the outer reaches of Earth's gravitational influence, our oceans will slowly return to quieter conditions. These are the tidal conditions that existed before complex life began its evolutionary journey. Humanity stands roughly 1 billion years away from losing total solar eclipses. We're several billion years from experiencing dramatically weakened tides. These timescales exceed the entire history of complex life on Earth. Yet they raise fascinating questions about future technological capabilities. Could advanced civilizations develop engineering solutions to prevent lunar recession? Could they construct artificial lunar replacements? The physics suggests some intriguing possibilities. These sound like science fiction but operate within known scientific principles. Theoretical physicists have proposed several mechanisms for halting or reversing lunar recession. These would use technologies that remain far beyond current human capabilities. Massive space-based gravitational anchors could provide additional attractive force. These would counteract the tidal energy transfer driving recession. Solar-powered orbital thrusters attached to the Moon could apply constant acceleration. These would maintain desired Earth-Moon distance. Controlled asteroid impacts could transfer orbital energy to adjust lunar trajectory. This could happen without destroying the Moon's structural integrity. The most ambitious proposals involve constructing artificial moons. These would use asteroid mining and space-based manufacturing. Advanced civilizations could potentially build multiple artificial satellites. These would have precisely controlled orbits designed to recreate Earth's current tidal patterns. These engineered moons could be positioned to provide optimal eclipse geometry. They would maintain tidal forces at desired levels. Such projects would require industrial capabilities that exceed current human technology by factors of millions or billions. Alternative approaches focus on modifying Earth's rotation rather than lunar orbit. This would maintain tidal energy levels. Theoretical orbital mechanics suggest that carefully controlled changes to Earth's rotational speed could alter tidal friction rates. This would influence lunar recession. Massive atmospheric engineering or controlled changes to planetary mass distribution could theoretically adjust the gravitational dynamics. These govern Earth-Moon interaction. These approaches would require planetary-scale engineering capabilities that remain purely theoretical. Perhaps most realistically, future civilizations might simply accept natural lunar recession. They could develop technologies to artificially recreate the beneficial effects of strong tidal forces. Artificial ocean circulation systems could replace tidal mixing. Engineered climate control could compensate for reduced oceanic heat distribution. Artificial illumination systems could provide lunar equivalent nighttime lighting. Rather than fighting cosmic physics, advanced civilizations might choose to replicate lunar benefits through technological substitutes. These would achieve the same results through different mechanisms. The moon's cosmic gifts could continue indefinitely. This would happen even after our natural lunar partner completes its billion-year journey toward independence.